Hey everybody, welcome back to my channel. And if it's your first time here, my name is Josh and I do a lot of videos on IT, cybersecurity, career, and some education stuff here and there. But today's video is going to be about data structures and algorithms 2, which is part of the Western Governors University Computer Science Program, or the Computer Science Bachelor's degree. I recently completed the Computer Science Bachelor's from WGU a few weeks ago, and I'm just now kind of going through and making videos about it and talking about my experience and talking about some of the more difficult classes. And data structures and algorithms 2 is one of the more difficult classes at WGU. So I kind of thought I would make a video, not really like telling you how to do it, but kind of explaining how I approached it that might kind of help you understand it a little bit better and be, I guess, maybe less afraid of it. Because there's a lot of requirements and it's a really big course. So if you're thinking about getting into the computer science program or you're already in it, this video will definitely be useful for you. So go ahead and watch it to the end. Set it at 2x if you need to. But yeah, let's get started. So just a disclaimer I want to throw out there. WGU has like sufficient material that you can use to kind of study and then learn what you need to learn to pass this course. But I didn't really use any of it because before I even registered for the program and started paying, I kind of pre-studied this course on my own. So the material that I talk about that I used is going to be the material that I used and not necessarily WGU's material. So if you're kind of wondering about that, that's why. I kind of studied this course before I even registered for the program. This is part of a kind of pre-gaming strategy that I used to complete this degree. Basically what that means is I completed a lot of classes and courses outside of WGU like study.com and straighterline.com, completed those, transferred them into the degree, and the courses that I had left, I kind of just pre-studied them before I even registered, like data structures and algorithms. For example, this course, I kind of studied it before I even registered, so then I could just kind of register, study them, register, and then just complete everything as fast as I could. So from the time I registered at WGU for the actual computer science degree, I only spent like 2 months completing the remainder of the coursework. So I spent 2 months and then got my bachelor's degree. So that's kind of why the resources I used are like outside of WGU, because I was kind of studying this course before I even registered at WGU, if that makes sense. But again, you can kind of learn more about that strategy in this video. I go into it like pretty in depth. But yeah, let's get started. Data structures and algorithms to strategy. So here we go. So basically the idea behind this class, without giving away too much, is you essentially have to programmatically deliver a whole bunch of packages all across Utah. And there's a lot of constraints that you have. So basically you have a given number of trucks and you can load up a certain number of packages per truck, and then you have to deliver all the packages within a certain amount of time, only driving like a certain amount of miles, if that makes sense. So you can kind of guess you have to do some maybe delivery route optimization and kind of a way to keep track of the packages and a way to keep track of which trucks have each package in them. And there's some other kind of pretty difficult requirements and constraints that go into it. But one of them is you have to be able to look up the status of any given package at any given time. You also have to implement your own hashing algorithm or your own hashing function, which you can't use one that's like native to Python. So there's kind of a lot that goes into it. It seems really insurmountable when you're just like reading the requirements for the first time. I can't share the actual requirements, but maybe you can kind of get an idea from this. So yeah, it's basically just it's like a delivery simulation, route optimization kind of thing that you have to do at WGU. So yeah, I'm going to break this strategy down to a bunch of different steps. You can just kind of see them here, but I'll go into them more in depth one by one. So kind of the first step is priming your Python ability. Python's a programming language for those who didn't know. This whole program, there's a requirement to use Python for it, and it's a really difficult application to build. So a lot of people might be like, okay, I got to get like super good at Python to do this. But like honestly, like Python syntax and using Python as a language is like the absolute least of your concerns. So there's a lot of difficult constraints and you have to implement your own data structure. So you have to know Python like, you know, a little bit, maybe even like at a superficial level, but more importantly, you have to like understand what you're doing in the application. You have to understand big O notation, time complexity, and you have to understand like a lot of different data structures, which I'll get into. But for Python, what I would recommend and what I personally did is I just used CodeWithMosh's Python course. I didn't even use it like all the way through. You can kind of see my progress here, like how much I actually used it. But this course is like really useful. It's really efficient in the way that it teaches you, and it got me me up to the level that I needed to complete this application. You can see I didn't even do like half of it. This course, if you purchase it, it also comes in handy when you're doing the computer science capstone final, because there's like a machine learning module at the end of this program that really comes in handy there. So I would recommend just using this. There's a lot of free Python tutorials that you can use online, which are probably good as well. I just happen to use CodeWithMosh for everything because it's so well put together, and I really like saving my time. So first step, just prime your Python. Don't worry about it too much. Just pick a tutorial and kind of go through it, and don't worry too much. So the next step you want to do is prime your data structures and algorithms skills and ability, I guess. This class is data structures and algorithms too, and not only do you use quite a few different data structures for this particular project, you have to implement one as well, which is a hash function, or a Hashmap, I guess. Specifically, I'll just tell you what I used. Again, I used CodeWithMosh data structures and algorithms to kind of get myself ready to understand the things that I needed to do in this class. Specifically, I used, I used like lists, queues, sets, Hashmap, and specifically graphs and maps. And you really need to understand what an adjacency list or an adjacency matrix is, because you'll use that pretty heavily in this assignment. So personally, I don't even actually know, again, I don't know what WGU's material was for this class, because I didn't even look at it, because I kind of studied this class before I even registered, and I just used CodeWithMosh. Especially the adjacency matrix sections were like really helpful. So yeah, get used to data structures and algorithms. I'll put like a bunch of links in the description. But yeah, that's pretty much step 2. Get ready, prime yourself in data structures and algorithms. So the next step after getting used to Python and after getting used to data structures and algorithms, now is kind of the time to start writing the actual application. So the first thing that I would do is kind of go and watch this video and learn how to implement a hash map, because you have to manually like implement your own hash map for this program. You can't use one that's native to Python. And this video is like really useful because it really like breaks it down for you and kind of explains what you need to do to make like the hashing function and how to handle collisions and all of that kind of thing. I deviated mine from this like a little bit. This might not make sense to a lot of people, but you don't have to have like a super efficient hashing mechanism. It's okay if you have a whole bunch of collisions. You just have to handle the collisions well. This will make sense more after you actually watch the video. But yeah, go ahead and watch this video, kind of learn what a hash map is, and go ahead and implement one in code for your application. And the next step in the process is to kind of read in the data that they provide and put that data into some kind of data structures in your program. So for example, they give you like a bunch of kind of Excel documents. One document contains like all the package information, like where the packages are going, like the address and stuff, and the weight and all that good stuff. And the other files are the destination names and then the destination data. Kind of the destination names, as you might guess, just includes the names and the addresses, I believe. And then the destination data, it's kind of like this table that shows the distances between all the different destinations, if that makes sense. So the distance between, for example, destination A and B, A and C, A and D, A and E, and then all the way down through the whole kind of destination. So you can kind of see like how far it is from place A to place B for like every single destination. So basically they give you these kind of data files, and they're all kind of messed up. They're in like a way that's not really readable for the computer. So what I would recommend, and what a lot of other people on Reddit do, is they kind of take these files and then turn them into just kind of raw CSV files, and like get rid of like all the other crap and like pictures and junk all over them, and just turn them into kind of raw CSV files to make them easy to read into your program. So you want to read these in and then put them into the appropriate data structure. And after you do that, you want to create an adjacency matrix or an adjacency list, whichever one you decide to implement based on your feelings at the time, I guess. You want to create an adjacency matrix. And the adjacency matrix, like I said, it just contains, essentially it's like a list of every single node that you're going to deliver packages to, and then with the distance from that node to like every other node, if that makes sense. So it's kind of a table that you will use later to kind of calculate the best path, or not the best path, but an optimal path when you're trying to figure out how to deliver your packages. So again, just to recap on this stage, take the data files they give you, clean them up so they're a nice raw CSV, read those into your program and put them in the appropriate data structure. And one of the data structures will contain your adjacency matrix that will be used to optimize your delivery routes. I'll go ahead and put a link in the description that shows how to read CSV files into Python. So the next step after you have loaded in all your package data and you created your adjacency matrix that shows the difference between all the nodes, the next step is to kind of load the trucks. That is, or choose like which trucks have which packages on them. And I know a lot of people tried to do this programmatically and it tends to take a lot of time. You'll see why this is when you actually read the requirements. But a lot of people, like including myself, kind of manually loaded the trucks, which is we just had a bunch of line of codes that just manually added like each package to each truck. It looks really janky, but it tends to save a lot of time trying to worry about the best way to like write some kind of algorithm to manually load the trucks. So for me, I actually created like a complete truck class, and you can imagine something like there's a truck class and then maybe it has some kind of data structure in it, like a set or something, I don't know, to kind of hold each package. And then there's like a function on the truck class that adds packages to the truck class. So you might have like truck1.add and then the object for package one, which would take that package and then add it to, the set or list or whatever data structure that I chose. So pretty much in this step, you, based on the constraints that they give you, just manually load all the packages onto the trucks. You'll have to like mess with this a little bit once you start delivering them. You'll kind of notice that maybe one truck takes too long to deliver the packages, or one of the packages is late based on the constraints. So you'll kind of have to, I had to like kind of massage my trucks and the loadout like a little bit, but just pick, just do it for the initial load, just load the trucks up and you'll kind of adjust which trucks have which packages later. But yeah, this step, load up all your trucks manually. I would recommend doing it manually, but load them up however way you want, I guess. And the next step, now that your trucks are loaded, now is the time to kind of choose which algorithm you use to kind of find the best route. I shouldn't say best route, but you need to choose an algorithm that at least optimizes your delivery route for each truck. So for example, we'll just say you loaded up truck one and truck one has 10 packages on it, for example. So I'm just going to show you like a little visualization of what I mean by choosing the algorithm and what that means essentially. So this is a website. I'll put the link in the description, but it kind of shows pathfinding and for the traveling salesman problem. So we'll say truck one has 10 packages. This is Salt Lake City. So maybe these 10 packages need to go to 10 different cities. So we have, or 10 different locations. So we have 6, 7, 8, 9, 10. And this kind of orange dot right here, you can consider this the hub, like the home base for the truck. So I'll save this. These are all the places we have to deliver them. And say that we'll do like a depth first or a brute force search. And what this is, it checks every possible path that the truck can take and it finds the absolute best path to deliver all the packages. And you'll see there's kind of a trade-off. So we'll check this one first. And this is kind of what the algorithm is going to look like. It's going to go through every possible path and try to find the absolute best route to deliver the packages. And you can see it takes a while, right, to calculate. And someone correct me if I'm wrong on this, but I think depth first brute force, it's something like n factorial, which means there's a total, in this case, our n is 10 because we have 10 nodes. It's going to check 10 factorial pathways. If you don't know what that means, you can just go to Wolfram Alpha, and then if we type 10 factorial, you can see it's going to check essentially 3.6 million different pathways. And at the end, it's going to find the absolute best route to take. So it takes forever to figure it out, but our kind of reward for that is that it's going to give us the absolute best path. So brute force is one way. If the path, it's absolutely imperative that you have the most optimized pathway. But another kind of algorithm that you can use, and this is the one that I used, is nearest neighbor. So basically, this operates in a time complexity of just n. You can see it's like, boom, it finished right away. Let me slow it down. So basically, nearest neighbor, as you might guess, it just starts here, and then it just says, where's the next closest one? And it's like, okay, it's here. And then it checks the other nodes, where's the next closest one? And you can see it just kind of keeps picking the closest node, and then it finishes like instantly. It's not necessarily the best path, but the time to calculate it was like super fast, as you can see. So it just depends on what you want to do. Some of them are, there's trade-offs. Nearest neighbor is like super easy to implement and it's super fast to compute. an optimized path. But the drawback is you don't get the absolute best path. And then there's brute force, which takes eons to compute, but your kind of reward in the end is you get the best possible, the most optimized path possible. And whichever one you pick, there's like a kind of paper component to this course. So whichever one you pick, you kind of have to justify it. There's not a right or wrong answer. So just pick one, implement it, and then you have to justify it. And then you have to talk about a couple other algorithms that you didn't pick and kind of talk about, you know, what are the benefits and drawbacks of those. So there's kind of a bunch of algorithms in here. I use this kind of website to pick my algorithms from, and I use this website for screenshots, and I used it to kind of help me understand what was going on, I guess. So this is, you know, convex hull. It's kind of interesting to see, you know. I think this operates in something like n squared time complexity. But yeah, basically the next step, you just have to pick your algorithm and then kind of implement it. And you might be asking like, well, what do you mean? Like, how do I implement it? So basically you use that data that we read into your program on step 5. And remember, we loaded the trucks up in the previous step. So each truck will have a kind of list of packages in it. And then you use the data we read in to kind of figure out where each one of the packages are. And then you have a starting point, which is the home base. So for example, if you're doing nearest neighbor, you just, you know, you assume you start at the home base, and then you look at the list of packages that you have on the truck, and you use your adjacency matrix and figure out which package is closest to where you are, and then you go to that package. And then essentially what I used a queue, so I went to the next closest package and I added that package or that node to the queue, and then from there you go to the next closest node and you add that to a queue, and then you go to the next closest one, you add that to the queue. All the meanwhile, you're also kind of calculating the time and distance it takes to go to each one of those nodes. And you can calculate the distance easily because remember, you have your adjacency matrix, which keeps track. Inside of the adjacency matrix, you have the distance from every single node to every other single node in there. And you can also calculate time from that because in the requirements, they'll give you something like the average truck speed is like, for example, 10 miles per hour. You take the distance and then you use the average speed to calculate how long it takes to drive, and you know, as well as the number of miles like to each node. So in the end, when you're kind of you loaded up the trucks and you're using your algorithm to calculate the time and stuff, you'll just keep track of everything from the time the truck leaves the hub and delivers all the packages, and when you deliver the last one, it has to drive back to the hub, and then you can kind of keep track of the time and distance based on the data you read in from the CSV files. I hope that makes sense. Maybe like watch this again or like read these other Reddit posts. I'll put them in the description. But yeah, I hope that kind of makes sense. This is kind of the meat of the coding part, in my opinion. And the next kind of thing to worry about is you have to keep track of time and like the status of the packages. So basically one of the requirements is, I'll just say this because it's kind of well known already, but you have to be able to look up any package at any given time, or you'll have to be able to look up, you know, the status of all packages at any given time. What this means is, like, what I personally did is I just kind of, for the last step, as the packages were being delivered, whenever a package was delivered, I kind of took a snapshot of all the packages during that particular time, like whether the packages were still in the hub, or they're en route, or they've been delivered already. So I kind of took a snapshot. Every time a package was delivered, I took a snapshot and I kind of stored it in a dictionary, if that makes sense. And at the end of the delivery, I kind of have this whole like data structure full of package status information at any given time. And at the end, in your kind of command line interface, you have to kind of implement the ability to look at packages at any given time and kind of display them on the screen, if that makes sense. So what I personally did for this is I used a nested dictionary, or a dictionary within a dictionary. So the kind of main key for the dictionary was whenever a package was delivered, I took that time and used that time as the key. And then for the value was just another, like a full dictionary set of all the packages and then their given status at that time. So for example, at 9 a.m. would be the key, and then the value would be a total list of all the packages in all of their statuses at 9 a.m. Or maybe another package was delivered at like 10:32. So there'd be another key that's like 10:32, and then the value would be like all of the packages and their statuses at 10:32. So when you're using the CLI to kind of look up packages for any given time, you would just enter a time and it would kind of pull all the packages and their status for that time. So that's pretty much all there is to it. Aside of this kind of difficult coding of the algorithm and keeping track of everything, you have to kind of write a command line interface for the user to be able to like interact with the program and, deliver packages and look up packages at any given time. But all of that is relatively easy compared to creating like an adjacency list and creating your own hashing implementation and all of that kind of thing. But yeah, I guess some general advice would also be, don't be afraid to manually do a lot of stuff in this class. For example, like manually load the trucks and manually do this and that, where of course you would want to like generalize it and like make it into some fancy algorithm normally. The class will be like much easier if you kind of manually do a lot of things. This probably doesn't make sense, but maybe once you start doing it, it will probably make more sense. And of course, take advantage of your course instructors. That's what they're there for. They're really smart. I didn't use one for this particular class because I kind of studied it like before I registered, like I said, but they're really smart and they'll be really helpful. And there's a lot of other Reddit threads about this course. I'll kind of put some of the best ones I saw in the description below. But don't give up. This class is definitely doable, especially if you kind of break it down like this and just take it one step at a time. Just don't worry about like anything else. Just when you're focusing on learning Python, just learn Python the best you can. When you're focusing on learning the data structures section, like your priming, just focus on that. Don't worry too much about it. The next step, when you're focusing on implementing the hashing algorithm, don't worry about the rest of the program. Just kind of focus on that and just kind of focus on one step at a time. And then before you know it, you'll kind of make your way through the program. And it's not that bad. It was hard for me, of course, but it's doable for sure. Just use this video and of course use Reddit, use your CI, and I think you will come out okay. So yeah, I hope this was helpful. I'm sure there's going to be a lot of questions, so please don't hesitate to leave questions in the comment section. I 100% respond to everybody's question. If you look at my other videos, I always respond. So please leave comments or questions if you have questions about anything. I'd recommend watching this video again. It kind of goes through my journey, I guess, at WGU Computer Science and talks about like a really manageable way to deal with it. I'll put some affiliate links in the description for CodeWithMosh. I use it. I really like his product, but again, there's a lot of free stuff on the internet too. But yeah, thank you so much for watching. I really appreciate it. Leave comments and we will see you in the next video. See you later.